This video is going to start our topic on probability. This lesson is on simple probability, and it's our first learning target. We're going to learn how to calculate the probability of a simple event and also use Venn diagrams to show possible outcomes as well. What is probability? Probability is defined as the chance or likelihood that an event will happen. We make this number by creating a ratio of the number of ways an event can occur to the number of possible outcomes. So our kind of general formula or general format for a probability is the number of events divided by the total number of events. So let's do this for this given spinner that has these numbers in this way. What is the probability of the spinner landing on a 3? Since there is only one section of the spinner that has a 3 on it, and there is a total of 6 different spaces, the probability of the spinner landing on a 3 would be a 1 in 6 chance. Probabilities are expressed both as fractions as well as decimals. So this is approximately 0.167. We could also express this as a percentage by multiplying this decimal by 100, which would be equal to 16.7%. We will most likely be giving our answers as fractions or as decimals. What is the probability of the spinner landing on an odd number? Our odd numbers are 1, 1, and 3. So this is 3 possible spots on the spinner for it to land on an odd number out of 6. This is a fraction we can reduce, so let's reduce it down to 1/2. So our answer is 1/2 or 0.5. You can also express this as 50% by multiplying the decimal by 100. Here is a group of marbles. Let's pretend like these marbles are placed in a bag, and then one of them is drawn out at random. Which color marble is least likely to be drawn? Well, that would be the one that there is less of. Since there is only one black, it is the least likely to show up. What is the probability of drawing a white marble? Since there are 2 white marbles, and there is 1, 2, 3, 4, 5, 6, 7 marbles in total, that would be 2 marbles out of 7, or approximately 0.29 in decimal format. What is the probability of not drawing a black marble? Since there is 1 black marble and 6 other marbles, since there is only 1 black marble, that means 6 other marbles are not black. So that'd be 6 marbles out of 7, which is approximately 0.86. Probability notation is a standard way of quickly writing down the probability of things. We write this with a capital P and then parentheses. Inside the parentheses is what the thing is we're looking to count up. For examples, P parentheses heads would be like for flipping a coin. What is the probability of getting a heads when you're flipping a coin? P6 could be many contexts, such as rolling a die. If you're rolling a die, there is numbers 1 through 6, so this would be the probability of rolling a 6. One of the most common ways to explore probability is working with a deck of cards. If you're unfamiliar with a deck of cards, here is what you can expect inside. There are a total of 52 cards in a deck. Again, 52 cards total. There are 4 different suits. There are diamonds, spades, clubs, and hearts in that order. Each of these suits have 13 cards. Consider the ace as being a 1 Then there's 2 through 10. Jack would be 11, Queen 12, and King 13. So there are 13 cards in each suit. The J, the Q, and the K, and the A stand for Ace, Jack, Queen, King. There are 2 black suits and 2 red suits. Let's find the probability of drawing a random red card. Since there are 13 diamonds and 13 hearts, that'd be a total of 26 cards out of 52, which is reduced down to 1/2, or 0.5. What's the probability of drawing a king? There is a king in each of the suits. There are 4 different cards with a K on it. So that is 4 out of 52, which reduces down to 1/13, or 0.77. What's the probability of randomly drawing a card with a number on it? Since there are 13 cards in a suit, and 4 of them don't have a number on them, that's the A, the J, the Q, and the K, there are a total of 9 cards left in each suit that have numbers on it. 9 times 4 suits gives me 36. 36 out of 52 cards have numbers on them. That reduces down to 9/13, or approximately 0.7. What's the probability of drawing a heart? There, remember, a heart is a suit of the cards, and there are 13 cards in a suit. So this is 13 out of 52, which reduces down to 1/4, or 0.25. Venn diagrams are used to show the amount of events happening together and separately. We draw 2 overlapping circles. The area to the left would be the space that has only the events from A. To the right would be only the events from event B. And where they overlap is where these things are happening together. There are many different ways to shade in Venn diagrams. If you only shade in the only A section, this would be the space that is only A and not B. If you shaded in the only B spot, this would be B and not A. If you shaded in the spot where they overlap, we would say this is A and B. And if we were to shade in both the sections that say only A and only B, but not include the section that says A and B, this would be the same thing as saying A or B. Look at the difference between the and the or. This will be important in our next lesson. Let's use this table about 11th and 12th graders that drive cars and those that don't to create Venn diagrams. We're going to first create a Venn diagram for 11th graders that don't drive. So in one side of my Venn diagram, I have 11th graders, and the other side, I have students that don't drive. So the overlapping space is the space where we have both students that are 11th graders and also don't drive. This is the 278 students that are both 11th graders and don't drive. The space to the left of this is the space that exists of 11th graders that do drive. 11th graders that do drive is 227. And the space to the right of the overlap are students that don't drive but are not 11th graders, which means they are 12th graders. And this is the 118. Now let's create a Venn diagram for 12th graders and those that do actually drive. The overlap is 12th graders that do drive. 12th graders that do drive is a total of 352. To the left would be 12th graders that don't drive. 12th graders that don't drive is 118. And to the right of the overlap would be students that still do drive but are not the 12th graders. That would be the 11th graders that drive. 227. You can manipulate tables of information to create different kinds of Venn diagrams. That covers all of our examples, creating our Venn diagrams, as well as working on probability notation, as well as creating very simple probabilities. Don't forget to hit the submit button, otherwise I will not have record that you participated in the video.